Good morning. Polynomial review. This is just going to be an overview of working with polynomials. In other words, we're going to classify them, add, subtract, multiply, and divide. Now remember, there's names as far as you want to classify three polynomials. You've got monomial, binomial, trinomial, and anything really above that is just they revert back to the general term of polynomial. Prefix mono, of course, means 1, so that would be something just like 12x. It could also be something as simple as 10. In other words, this has no variable, but it's still just one term. You could even have something like 16x squared y cubed z. Still all multiplied together, still one term. Binomial means two terms. So it could be something like x squared plus 8. It could be 9x minus 12. It could even be something ugly like 8x squared y cubed plus 4x squared. It's still two terms. And finally, trinomial, of course, 3 terms. We'll just say that. And like I said, anything above that is generally reverts back to polynomial. Now, the second part of classifying as far as degrees, remember, you see degrees has to do with the highest number of variables or exponents, or let me rephrase that. Okay, degree is if you look at the variables in each term, the highest total power that's there. So like, let's say this one, x squared, x, and 10. In this term, we have 2 x's. In this term, we have 1x, because remember, I understood 1. This term, we have no variables. And the most common mistake is adding them up, but you don't. You take the highest of what's represented. So that would just be degree 2. Let's say, for instance, this one. You've got 2 x's and 3 y's, so this one's got 5. 2 x's, so this would be degree, you guessed it, 5. We'll take this one. 2 x's, 3 y's, 1 z, degree 6. Now this one, a constant, in other words, no variable, there's literally no variables there, so that would be degree 0. So that's how you do the degrees. Now the fun stuff. Let's say if I wanted to add some, just put down whatever number comes first in my head. If you want to add, you simply add the terms that are alike. Remember, the variables have to be the exact same variables represented and the same power. In other words, I've got x squared, and there's understood 1. So 1 plus 3, 4. And I always cross them out, because if it's a messy one, that way you can tell, hey, I skipped one, I should have included this. It's just a good, helpful hint for you. So then I just keep on going left to right. I got an 8x minus 4x plus 4x. Negative 11 and 12, positive 1. And you're done. Let's do a weird one. Okay. Yeah, I know I could have done better, but still waking up this morning. Well, 2 x's and a y, 2 x's and a y. So 1 plus 6, 7, x squared to y. Then we come across to 5x. There's no other one like it. So just bring it down. Then we've got a y. Aha! So negative 2 and negative 12, negative 14. X squared, there's only one of those. There you go. Well, let's subtract some. Now, remember, subtraction is considered the same thing as adding the opposite. So if I want to add opposite, 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 change all signs, always in the one after the subtraction symbol. Never, ever mess with the ones in front. It's always minus or add the opposite of those. Once you get to there, it's just like we were doing. X squared and x squared. So 4 minus 2, 2x squared. Negative 10 and 12 plus 2x. And 14 minus 8 plus 6. All right, let's do a weird one. We'll do one more. One I was going to do something similar a minute ago. All right, well, on this one, same thing, minus. So add opposite, opposite, opposite. So we got 2 x's and a y, 1 x and 2 y's, so totally different. 2 x's and a y, so negative 9. 1 x, 2 y's, 1 x, 2 y's, so 25, because 16 and 9. Just bring it down, because that one only has 1, so it has to stay by its lump sum. So now we multiply. Now in multiplying, first we can just do by monomial. Let's say if I had 6x times 6 squared, 9x minus 3. If I had something like this, you're just going to distribute the 6x by everything inside. So 6x cubed plus 54x squared minus 18x. There's nothing else you can do with that. So you're done. Let's say we'll make a little messier. Something like this. Monomial by binomial. Distribute. So 18, 3 x's and a y, minus 33, 2 x's and a y. So just be careful on those. But if it's a monomial, that's it. But let's say it's 2 binomials, which is where some of you have heard the full method. All of my students have. At least they better. So, first, outer, inner, last. You don't have to do it in this order. This just helps you not miss over a term. Like I said, you don't have to do it, but it does give you a nice pattern for those that like patterns. So first terms, x times x, x squared. Outer terms, x times negative 3, negative 3x. So notice how basically all we did was, just like we did up here, distribute the x to both of them in the other parentheses. Now enter. Which are those two? 2x. Last, -6. So notice how basically where this comes from, you're just distributing your first one to both, distributing your second to both. Simplify what you can. -3 and +2, -x, -6. Let's do another one. Let's throw in some coefficients up there. Let's say something like this. First terms, 2x times 3x, 6x squared. Outer terms, 15x. Inner terms, -8x. Last term, -20. Add what you can. The x's, 7x -20. They could even, if they wanted to really get unique, they could even throw variables on the end. Well, just like with most math, they could always do something to spice things up. But you still do it the same way. Let's even throw an x squared in there just to make it ugly. So that gives us 2x cubed -5, 2 x's and a y. Inner terms, 6xy. Last terms, -15y squared. And since I threw that in there to make it ugly, you actually can't do anything else because nothing can be combined. All right, let's do another one. What about 5x plus 6, 5x minus 6? And I know some of you are thinking, oh, those are about the same. Yes, they are. Anytime with a binomial or two terms, you have the same numbers in the front and the back and opposite sides in the middle. Remember, they're called conjugates. We also do them with square roots, but that's for another chapter. Now, something special when you multiply conjugates. Notice how you start off normal, first terms. You even do the outer terms, -30x. Inner terms, +30x. Last term, -36. Well, when you try to combine terms, notice what happens. 30 and -30 cancel. That leaves you with just 25x squared minus 36. So there's a shortcut. Whenever you have conjugates, you don't have to use it. You can always FOIL and get the right answer. But let's say, to work through it with a shortcut, since the outers and inners you know are always going to cancel, if it is a true conjugate, you can just do first 16x squared minus last. Now remember, if you don't like the shortcut, you don't have to deal with it. I like to give you all options. Now let's say if I did x plus 3 squared. This is not x squared plus 9. To be honest, that's 2/3 of it, but it's not the whole thing. Because if you have a plus sign, you can't just individually square things along. It just does not work that way. So remember, you have to write it twice. And then you can FOIL. X squared plus 3x plus 3x plus 9. So x squared plus 6x plus 9. So you see it does have the x squared and the 9, but you had to do FOIL to get the middle. Now, for those of you that like shortcuts, there is a shortcut for this one too. This one's not as common as conjugates, but it's out there. To find it by actually not doing the FOIL method, and the shortcut is square the first one, then multiply those two. So x and -4, -8x, square the last, 16. You don't have to do it the shortcut. It only works on those. Same thing. I always like to help you out when I can, give you shortcuts, whether it's ACT helps or whatever. Now, let's get fancy. Let's say I give you this, so we get to fancy form. All you have to do, basically, you're going to distribute the x to everything inside. So that'll give you x cubed plus 8x squared minus 9x. Now we're going to distribute the negative 3 to everything. Negative 3x squared minus 24x plus 27. Add anything that's alike. So you've got x squared, so 5x squared. Negative 9, negative 24, negative 33x. Plus 27. They can get a little messier than that, but for time's sake, we'll stick with that. Let's say that I give you this. We'll do last but not least dividing, because I know some of y'all are probably getting tired. Dividing, if it's a monomial, this is the same thing as, of course, writing it underneath, which is actually what I prefer. And all you're doing is dividing this by 7xy and this by 7xy. So remember, if you wanted to rewrite it, now some of you will get to the point you can do this in your head, and that's fine, but I just didn't want to lose anybody. This, if you put it underneath both of them, you just reduce. So 7 goes into 14, 2. 2 minus 1, 1. Y's cancel. Bring down the plus. 7's cancel. 2 minus 1, 1. 2 minus 1, 1. That's all you can do. But I know most of them are not that way. Let's say if I had this. You would either have to do long division or synthetic division. We'll do synthetic division because it's actually my favorite. Even though long division does have its case in finding the asymptotes of hyperbolas and different things, but synthetic division is probably a little bit easier for some. Remember, you start off with a box and a horizontal line. Up here, you're going to put just your coefficients. Make sure there's no gaps. 2x is 1x, no x. So that makes it 1, negative 9, 15. Now to figure out what goes in the box. Remember, when you divide, you always, after you multiplied, you subtracted. Well, to take care of that so you don't have to worry about it, you always put, in a sense, what makes this 0. Or you can think about it as the opposite, but technically it's what makes it 0. So what minus 1 equals 0? Positive 1. Remember, bring the first one down. 1 times 1 is 1. Negative 8. Negative 8 times 1, negative 8. Remainder 7. And then to write your final answer, x goes into x squared, x times. So it's always 1 less. Constant remainder. Let's do another one. Let's put a coefficient out there. We'll do 13. Maybe this time we'll divide by x plus 2. Maybe that won't be too bad. Well, x plus 2, so what makes it 0? Negative 2. Then put all your coefficients, 2, 4, negative 8, negative 13. Bring down the 2. 2 times 2. Ooh, looky there. -4. 4 minus 4 is 0. 0 times anything 0, -8. -8, -2, +16. Now put your coefficients in. 3, 1 less, 2. You can put the 0x. You technically don't need to because it's 0. Constant. Remainder. Last but not least, long division. Long division does have its case. I know air freshener scared me. Most of you hate it, but it does have its purpose. Let's say x into x squared. Think of it as like that. X goes into x squared x times. Now remember, you multiply by both of them. So x times x, x squared. X times 3, 3x. And remember, you're always going to change your sign to both. So -8, -3, -11, plus 13. And now x goes into -11x. Remember, this is all I'm doing. -11 times. So -11x minus 33. Always change your signs. 46. Let's do another one. What about if there was a coefficient? Wrong type, sorry. We'll say, we'll just see where this leads us. So x into 3x squared, remember, I'm just doing that, 3x. So then 3x times each, 3x squared plus 12x. Change your signs to both. 6 minus 12, -6x. Bring that one down. X into -6x, -6 times. -6x minus 24. Change your signs. Looky there, we almost had a 0 remainder. If only I'd made that a 24. Oh well. So that is long division, or at least the easier cases. If you had x cubed, you do it the same. Let's see. I don't want to do that one. That one's on your review worksheet. Hope this was of help to you. If you want to see more, or if I didn't answer all of your questions, as always, comment, and I will be quick as possible to help you figure out where your mistakes were and how to do it. Hope you have a great day.